There is a table that shows the number of women's shoes that were sold one day at this smart shoe shop. What does it tell us to do with that table? Make a what? Yes, relative frequency bar graph. I think almost everybody just gave me a regular bar graph, which were beautiful bar graphs, but they are not relative frequency bar graphs. When you hear relative frequency, what do you think? So what? Anything else? What do we do to find a relative for relative frequency graphs? Not averages. You're right, though, that they like relate to each other in a different way. Relative frequency. We looked at relative frequency when we were looking at circle graphs, relative frequency circle graphs. What did we find in order to create a relative frequency circle graph? What, Tian? Yeah, percentages. When you hear relative frequency, I want you to think percentages. Percentages. So how it relates to the whole, right? Okay. So if I'm going to find my percentages, like each category, if I want to find the percentage, what am I going to do? Add them all up. Let's add them all up. What's 18 and 12 equal?
30.
And what's 6 plus 9 equal?
15.
And what's 15 plus 15?
30.
What's 30 and 30?
16.
There you go. We got our total. So now what? Fractions first. Yeah. So tennis shoes. What's my fraction for tennis shoes? Good. Let's just write out all our fractions first. What about loafers? 12 over 60. What about heels? Low dress shoes, whatever that means. What's my fraction? Thank you. And then for walking shoes? Good, 15 over 60. So now I've got my fractions. How do I change those into percents? Yeah, I would divide it and then what? Yeah, divide and then multiply by 100. But, and you can use your calculator, that's just fine. But instead of using our calculator, let's use our brains. Does anybody know what 6 out of 60 would be as a percent? 10%, perfect. So if 6 out of 60 is 10%, what would 12 out of 60 be? 20. Right, because 6 doubled is 12. So let me just double the percent as well. So then what would 18 be? 30. Yeah, why 30? Yeah, because 3 times 6 gives us 18, so 10 times 3 gives us 30. Why is it 15? Yeah, 18 divided by 2 gives us 9, so then I just half my percent. And then how would I figure out 15? Why do you say that, Emilio? Huh? Because it's a fourth? How do you know that, though? Yeah, 15 and 15 is 30, and 30 and 30 is 60, so 15 is a fourth of 60. Or you can think about time, right? 15 minutes is a quarter of an hour. Yeah, so a quarter of 100 is 25. We could also think about it by adding up the other percentages and just seeing what's left over.
So do you, to find out the percentages, do you multiply them first and then divide them by 100?
Nope. What do we do? Yes, divide and then multiply by 100.
Oh, okay.
And then we could also think about it like 12 plus 3 gives us 15, right? 12 out of 60 is 20%. And then 6 out of 60 was 10%. So that means that 3 out of 60 would be 5%. Then I got 5% and 20%, 25%. Right? So there's like a million different ways to think about percentages. And we all kind of like tend toward one way. And you might just totally just want to use your calculator on it, and that's fine. But percentages come up a lot in the real world. So it's good to start thinking about them in different ways. I really love this, like finding 10% of something, and then that makes it really easy to find 20% or 30% or 40%, because you can just take that and multiply it by 2 or 3 or 4. Okay. Okay. So cool. So I got my percentages. Is that all I have to do? What do I have to do now? Yeah, I gotta make a bar graph. And basically a relative frequency bar graph is just the same as a regular bar graph, except for instead of using the numbers of shoes, we're going to be using the percentages. So along my x-axis, I'll put all my categories. Got T for tennis shoes, L for loafers, H for heels, D for dress shoes, W for walking shoes. Go up by 10 up to what? Good. 5, 10, 15, 20, 25, 30. So tennis shoes is 30%, loafers is 20, heels is 10, dress shoes 15, and walking shoes 25. All right. So you might put that whole entire problem onto your notes page, or you might just put a step in there. It's totally up to you. That notes page is just for you. So think about what do you need to remember for a problem like this and get that down on that paper. I think the big thing is that when you hear relative frequency, what do you think? Percentages. Cool? Any questions on that? Feel okay? Cool. All right. Let's take a look at number 2. And for number 2, I want you to make a little note under the 2 variable data section on your notes page. There's a couple things I want you to write down. First thing, let's write a little coordinate plane and label our x-axis and our y-axis. And then to remember what our different quadrants are, we want to write a C on the coordinate plane, and that tells us where to start and where to finish. Right? So I've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in quadrant 1, well, first of all, when I write an ordered pair, what letter comes first? And then, and X tells me the horizontal position of a point. What does the Y tell me? Vertical. Still seeing a lot of mistakes on that practice page from yesterday. So please make sure you get that down. Please make sure you double check yourself. Make sure you're thinking left and right first and then up and down. Okay? And in the first quadrant, is my X coordinate going to be positive or negative? Positive. What about my Y coordinate? Also positive. Good. And then what about in the second quadrant? X is what? Negative. And Y is? Yeah, still positive. What about third quadrant? Yeah, negative, negative. And fourth? Perfect. Positive, negative. Cool. So that information should be in that 2 variable data section of your notes page. And then let's take a look at these problems. So number 2 says name the points in quadrant 2. What points are in quadrant 2? Good. Why not C? Yeah, it's on the y-axis, so it's not going to be in any quadrant. And what about number 3? What points have coordinates that are both negative? Good. G, H, and I. Why not J? Yeah, so I mean the y coordinate of J is negative, but the x coordinate of J is what? 0, and 0 is not negative. 0 is 0. It's in between. G, H, and I. And then number 4, we're looking at the points that are on the axes. What points are on the axes? C, F, J. Is that all that question asked for? What else did it ask for? The coordinates. What's my coordinates of C? Good. 0, 3, F. Perfect. And J? Excellent. Okay. These next couple questions all have the same format. Oh, I just realized this has pockets. Didn't notice that until just now. Anyway, where we got to fill in the blank with always, sometimes, or never. So median and mode, this one's asking about. What is the median? The middle number. What is the mode? Good, most common. Why do you say sometimes, Sean? Anybody else have reasoning? Can we come up with an example where the median and the mode are the same thing? 9.7. Can I do 9.3? Right? And then, right? So my 9s would be in the middle, so that would be my median. And then it's also the most common, so it's the same. Can you tell me a data set where the median and the mode are not the same? 59 and 25. Right, the median would be 25, and there is no mode, right? So they're not the same. So yeah, so they are sometimes the same, sometimes not the same. Let's take a look, next page. I don't like number 6. I'm not going to put this on the test. For the sake of this class, yes, scatter plots will always be 2 variables, but like I showed you yesterday, I guess technically like we could have a 3 variable scatter plot. So that would be a better way to say it. I don't know. I don't like that question, so we're just going to move on from there. But yes, always in this class, we're always going to have just 2 variables. I'm not going to throw a 3 variable thing at you. Number 7. If you are going to leave right now, can you come over here and grab this paper, please? Who is it? Huh? Is that just like one? Is that just like one? Oh, that looks like one whole package. Oh, just to keep this up. Evelyn, do you go? Tina, you don't go? No, I got a list of people. That's because we're oh, but you guys are going later. Yeah. Okay. Do we take these as well? Yeah, take those. So those is it just Lexi and Tia? No one else? And Wyatt? Okay. So you guys, I would like you to take the test home with you. Hey, can you please keep this out for a second so I can give them instructions? Take the test home with you. Okay? I'm going to post the video online if you need help getting through it or you have questions about anything. It'll be on Google Classroom. And then you're going to take this paper home, and I'd like you to correct your mistakes on here and bring it back on Monday. Okay, so come on up so I can give it to you. And then Wyatt, come grab this paper before you go, okay? All right, everybody else. We got to keep going. We don't have a ton of time. Outliers. I've never talked to you about that word before, but does anybody know what it means? Go ahead, Damon. Exactly. So, exactly. So if I have a dot plot, and I have most of my data points over here, can you guys just pass this over to Wyatt, please? Grab that before you go. So if I have a bunch of data points over here, and then I just have like one over there, that one would be my outlier. Yes, sometimes. Sometimes, not always. What about this? A mean is always, sometimes, or never the outlier. Never, right? Yeah, because the median's going to be somewhere in the middle, right? The outlier is never anywhere close to the middle, so mean is never going to be an outlier. What about number 9? Sometimes, right? Sometimes we don't have a mode. 1, 2, 3, 4, 5, no mode, right? All right. Number 10, I got some interesting answers on this one. Well, yeah, it's not a dot graph, it's a dot plot. Well, it's not, because plot and graph are different words. Okay, let's find mean, median, and mode. Mode is 7, right? Because it's the most. Good. Let's find the mean. Let's find the mean. Let's do the mean. How do I calculate my mean? Write this down if you forget. Add all the values, divide by the number of values. So let's just find it together. Can someone read to me the points on the graph?
6, 6.5, 6.5, 7, 7, 7, 7.5, 8.
Good. And let's add those up. What's 6.5 plus 6.5? What's 7 times 3? What's 7.5 plus 8.5? Good. So now I've got this. What's 6 plus 13? What's 19 plus 21? And what's 40 plus 16? Excellent. Good. Who needs a calculator? 56. And what do I divide that number by? Which is what? Good. What's 56 divided by 8? Excellent. There's my mean. How do you know the median is 7? How do we figure it out? Yeah. Since I already have my dot plot, do I have to rewrite them all in order? No, I can just cross off the dots. So 8.5, 6, 7.5, 6.5, 7, 6.5. And then I end up with 2 medians. Does that mean that I write 7 2 times? Yeah, technically you find the average of those two numbers, but since in this one it's just they're the same, so finding the average of 7 and 7 is just going to be 7. But that's right. Yeah, if you add them together, you get 14, and then divided by the number of values, which is 2. 14 divided by 2 gives us 7 again. Can you ever have more than one median? No, only one median. Only one median. You won't get in trouble, but you will get it wrong. So we find the average if there's 2 numbers in the middle. Can you have more than one mode?
Yeah.
Yes. That might be a good thing to write down. Only one median. You can have more than one mode. And what about range? How do I find my range? Yeah, max minus min. What's my max from this data set? And my min? What's 8.5 minus 6? 2.5. That was kind of a weird 2. It's okay. 2.5. Cool? Questions on that? Mean, median, mode, range? We feel good? Great. Make sure you got the definitions down if you need that, or if you forget. Let's go on. We're going to skip 13. Don't worry about 13. Let's look at 14. What does 14 tell us to do? And then what? Yeah, we got to make a histogram. What am I going to do to make a histogram? Yes, I am going to do that eventually, but what do I do before I start graphing it? Huh? You could put them in order, but they're already in order. Not percentages, not for histogram. What do we? Yes, the bins. How are we going to figure out the bin width? It is. It says it, yeah. Choice of bin width. How are we going to figure out bins? Yeah. It's like the number of groups and how we're going to kind of split up our data. So what do you think we should do for this data set? Cut it in half? What are you thinking about? That's not histogram. That's stem and leaf. Oh, sorry. Like on here? I don't know what you mean. Okay. How can I figure out how to split up my data into different bins? But how big do I make my bins? So just do 2 bins?
Would you divide it? Would you divide it by like how many numbers you have?
Divide what?
Like so count all the numbers and then like divide it by I don't know, like trying to come out like 3 or 4 answers by an equal amount of numbers. You know what I mean?
What?
At least you're offering ideas. That's good. You're on the right track.
Range. So like 60 to 64.
Yeah, that's what I was trying to say. Like the range. Yeah.
You want to do 60 to 64? Let's do that. So what's going to be my next bin? What's going to be my next bin?
65 is
What?
64.
There it is, 64 to 68. So bins are continuous. Where they end, they start again. Beginning. Every ending is just a new beginning. What's my next one? And then? 72 to what? Why 75? So there isn't a 76, but we have to make our, you're good, this is a good question. We have to make our bins equal width. So this has a width of 4, that has a width of 4, that has a width of 4. If I made that 75, that would have a width of 3, right? So I gotta go to 76. That's good. Yeah. No, that's good, you guys. That's really good. Right? Good. So, okay, now we've got 4 bins. That's a good place to be. Can we figure out how many go in each bin?
Yeah.
Okay, how many go in that first bin? 60 to 64.
Yeah, both groups.
Both groups. 6?
Five. Wait.
5?
Three.
Why do you say 3?
I say 3 because 64 cannot be in the bin.
Right? Boundary values always go to the next bin. So 64 is going to go in that one. So for this first bin, it's just 60, 62, 63. These are histograms. This is a good one if you want to just copy this whole problem down into your notes section. I think it's a good idea to have like an example. How about 64 to 68? How many do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. 68 to 72. 1, 2, 3, 4, and 5. And 72 to 76. Good. 1, 2, and 3. All right. So this is like essentially a frequency table, not a two-way frequency table, just a regular frequency table. And that's what our first step is in making a histogram. What's going to be my next step? Yeah, graphing it. So I've got a y-axis and an x. It's essentially a bar graph at this point, but there's a little bit of a difference. So on our bar graph, we just put like T, and then whatever the bar was for T, we did that. And then L was totally separate. You got to put your ranges on there, and really the bars should be connected. They shouldn't be separated. So what am I going to put along my x-axis?
Five notches.
Okay, no, so 60, 64.
And then do I rewrite and do 64 to 68? No.
68. 72. 76.
Excellent. And then what about my y-axis?
Move it up to your highest one.
Yeah, your highest frequency. So, yeah, 1 to 10 or 1 to 9 is good. So 1, 2, 4, 6, 8, 9, 10, 10, 8, 6, 4, 2. So 60 to 64, that goes up to 3. 64 to 68 goes up to 9. It's over here. 68 to 72 goes up to 5. And then 72 to 76. What are you going to do with it now? Okay. Right? Okay. Our histogram. Questions on the histogram? You feel okay about it?
When you do it like 1, 2, 3, 4, can you do it like 2? Does it really matter?
No.
Okay.
No. If you put in 1, 2, 3, 4, 5, 6, 7, 8, 9, that would be fine too. I didn't have enough room to write all my numbers. Okay. There we go. There's our histogram. Now let's take a look at this graph. So this graph shows the speed of a car being driven by a mother taking her kids to school. So the y-axis shows us our speed. So the farther up you go on the y-axis, the faster she's going. And then time is shown on the x-axis. So as we move along the x-axis, it's like as time moves on, right? Between which 2 points did the mother accelerate the most? And why do you say E and F? Good. Steepest slope. Perfect, right? Oops. E and F, yeah? Steepest slope, meaning the speed increased the most in this like short period of time, right? And then what might the driver have been doing in the time interval between D and E? Good. Why do you say stopped? Yes, exactly. That's perfect. That's it. The line is constantly at 0 right there, right? Because B through C, there's no slope for that one either, but that's them going a constant speed, whatever that speed is. Whereas this one's along the x-axis, which means it's 0. And then what about between F and G? What? Yeah, braking or slowing down. Perfect. And why do we say that? Huh? Yeah, the speed is decreasing over time. Perfect. That's it. Number 17 is just mean, median, and mode again, so I'm not going to do another example on the board. You okay? If you need more help with mean, median, and mode, come and see me during lunch on Monday. Okay, that's on you. And that's it. That's it for that.